Mr. Stat Sensei, Mr. Spensei, and this is 3B.2 geometric distributions, and this is scenario 2. It says studies show that 17% of teenagers who experiment with marijuana develop a dependency on the drug. So let's talk about this real quickly. So I have 17, I divide it by 100, and I find out my probability is 0.17. By the way, this is actually real data. And you're like, well, what's the difference between this and scenario one? Scenario one said 9%. Adults have a lower dependency rate than teenagers. Teenagers, if they experiment, have a 17%, which is basically 1 in 6. So 1 in 6 teenagers is approximately 17%, whereas it's about 11%. If the entire population is about 9%. Yeah, 1 in 6 is about 17%. Of the teenagers in the US who have used marijuana, how many would you expect? There's my keyword expect. So they want me to use the expected value. So I'm going to write this formula, and P is 0.17. So I'm going to go 1 divided by 0.17. 1 divided by 0.17. And we get 5.88, which, as I told you, is pretty close to 1 in 6. Not exactly 1 in 6, but pretty close. What is the standard deviation? Well, here's our standard deviation formula. Well, that's going to be the square root of 1 minus 0.17 over 0.17. So I'm going to plug that into the calculator like this, parenthesis 1 minus 0.17. And then I like to use a little caret to the half power, and I'm going to divide that by 0.17. And I get 5.35. There's my work shown. What is the probability that the 10th teenager you interview from the population of teenagers who use marijuana is the first? Soon as I see the word first and I don't have a group, if I don't have a group and I'm looking for the first, I'm thinking this is a geometric. So I make my number line super important, and we're looking for the 10th person. All right, so the first success, this is what tells me it's a geo, but we're looking for the 10th person. My probability is still 0.17. My x value is going to be 10. So my formula is going to be 1 minus 0.17. And then that 10 will be my x minus 1. So let's go ahead and run it, and then we'll show our work. Second vars, geometric, PDF, 0.17. My x value in this case is 10 because we're looking for specifically the 10th person. And because we're only one, if we're only looking for one, we're using a PDF. We're using more than one, then we are going to use a summation. So this is a PDF, and we get 0.0317. So let's show our work. As I said, here's our formula. So 1 minus the 0.17. Now I've highlighted 10 over here. Guess what? That's what I plugged into the calculator right there. And this is that same 10 showing up right there. And that's our work shown. Letter D. What's probably the first teenager? Once I see that word first, it's like, oh, this is a geometric, is among the first 12. Whoa, we have a group. I'm circling more than one. If I'm circling more than one, this lets me know it is a summation. Now, with the summation, we're going to care about plugging in because we're going to do this by bookends. We'll have the lowest value plus dot, dot, dot plus because it could be the first one, second, third, all the way to the 12th. All right. So this X will be the 1, and this X will be the 12. I don't know if you can see that. You can see the green. I don't think you're going to see yellow on yellow. Probably not the best color, but anyway, there we go. That's what we have. So in this case, our probability is still 0.17. So all the probabilities are going to be 0.17. Those don't change. The thing that's going to change is we need a summation, and we need a 1, and we need a 12. So let's go ahead and try that out. So we're going to go, excuse me, we're going to turn the lights back on, and then we're going to press the math button, and we're going to drop down to summation, and we're going to press X. Well, the low value is 1, the high value is 12, and blue second vars, geometric, PDF, probability is 0.17. But anytime you use a summation, do we use a number? No. Anytime we're using a summation key, we use a X. So we go to the XTON button, and there we get 0.8931. So once again, really want to point this out. This one matches to that one. This 12, which is my upper up here, matches to that. And we get 0.8931. This is our work shown because this is the P. Notice the probability never changes when we plug in the P's. Letter E, of the population who uses marijuana, what's the probability of the first teenager? So I see the word first again. When I see that, tells me it's a binomial. I see the word first. This tells me it's a geometric. You interview with the dependency is the first teenager. So we want to know the probability it's the first one. Well, guess what? This formula, but guess this X right here is going to be just a plain old 1. So sure enough, that's what we have here, 1. And this always this first one. Probability is still the 0.17. Second vars, geometric PDF. Change that to a 1 because we want it to be the first person to be the first person, and it's just our probability of 0.17, and that's correct. Letter F. What's the probability the first teenager with a dependency on marijuana is among the first 4? So I have multiple values. When I have multiple values, that tells me it's going to be a summation. And the one that we're going to care most about is this first one and the fourth one, because we're going to do bookends, because it could be the first, second, third, or fourth, but we're just going to show the work for 1 plus ... plus 4. So this will be the first one, and this will be the fourth one. So there it is. Here's our fourth one. Here's our first one. If you notice, once again, the probabilities remain the same all the way through that point. Every time we have a probability, it's still 0.17. It doesn't change. Okay, so as I continue on, let's try this out in the calculator. All right, so we hit the math button, arrow down to summation, and we press X. We wanted 1 is our first one. That's our low value. Our high value was 4. Arrow over, second vars. We're going to run a geometric PDF. Probability is 0.17. And our X value, if we're using a summation, anytime we use a summation, we have to use X because it can be any one of those values. And we get 0.5254. Letter G. Of the teenage population who uses marijuana, what's the probability the first teenager? Once again, there's that word first. First tells me it's a geometric. Every time I see those words first, I'm like, first. It tells me it's a geo with a dependency is the third. So what we care about is the third, specifically the third one. And it's only a single value. If it's only a single value, this means it's going to be a PDF. It's not going to be a summation. So X equals 3. So that means I'm using this formula where this is going to be 3 minus 1. And our probability of course, is going to be 0.17 all the way throughout. So, and here's that 3. 3, 3, 3. Notice how it keeps showing up. So, second vars, geometric PDF. This is 3. And we get 0.1171. Okay, finally, letter H. Of the teenage population who use marijuana, what's the probability that you need to interview at least 3? No, I have at least. At least is awful. When I see at least, I know I have to do 1 minus the summation. Okay, so at least 3, 1 minus the summation. That means what I'm looking for. This is what I care about. I can't go to infinity on a calculator. It won't do it. So what I have to do is a summation or 1 minus the summation of these first 2. where this will be my, and anytime we have a summation, we're going to do the bookends plus dot 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 plus. So this will be my low value, this will be my high value, which means on my when on my formula, we're running out a little bit of room here. On my formula, this will be my one, and this will be my two, because this is my lower value, this is my upper value. And notice that matches exactly to what we have here. Here's my low value of one. Here is my high value of two. So we can go ahead and plug in. Our probabilities are all the way across the same. This is the two that shows up there, and this is the one. All right, and we're always subtracting one with these. It doesn't matter what the values are. So let's try this out. 1 minus, now we need our summation. So we press the math button. We're going to drop down to summation. And we have x equals the low value up to the high value. Second vars, geomet PDF. And anytime you use summation, do you have a number? No, no, no. You never have a number, Mr. Spencer. You always have an X. And we do that, we get 0.6889. Okay? All right. Didn't mean to cut those off, so I'm going to put that right there so you can see everything, because that way you see your calculator commands as they went in. I hope that helped, and I sure look forward to seeing you on the next one. Good luck.